Okay, let's do the sample standard deviation in this video. So let's say of those 7 workers that we had in the previous video, you took a random sample of only 3 of them, and you found that their travel time to work was 5, 26, and 36 respectively. So between those 3, you can come up with a new average. X bar is all those added together divided by 3. This is 67 over 3, which is 22.33 repeating. So we write out our numbers, 5, 26, 36. We've got 22. I'm going to just round it to 33. Subtract. 5 minus 22, that's negative 17.33. This one is 3.67, and this is 13.67. Now I need to square these unfriendly decimals. Negative 17.33 squared is 300. We'll just go 33, round to 2 decimals still. 3.67 squared, 13.47 rounded, and then 13.67 squared, a little bit bigger than that, 186.87. Still the same strategy though, we still add them all up together. So 300.33 plus 13.47 plus 186.87. Which is 500.67. So we know our sample standard deviation, that's the thing always in the numerator when you add them all together, 500.67. Now, in the population, we would have divided by 3. In a sample, the mean was affected by all of the numbers, and normally populations can be almost infinite, which is the reason that you do it divide by n, because you're picking basically an endless amount. So we have to divide by 3 minus 1, which is just 2. So the sample standard deviation is 500.67 over 2, the square root of that. So the sample standard deviation is approximately 15.82. So again, that was only 3 numbers, but this is not the most fun thing to do. Now, question 2 here is designed for you to put them both in your calculator. If you want to do them by hand and check the differences, you can. I would suggest you practice doing these in the calculator. One thing to note is the standard deviation on B will be smaller than A. That's your first hint. And there's a reason for that, and you can figure it out moving forward, but I want to leave it up to you to kind of practice doing this. Now, another measure of dispersion is the variance. Well, the variance is simply the standard deviation squared. So instead of taking the square root, you're done without it. So if you recall back to our problem here when we changed this to 6, we got a standard deviation was the square root of 864 over 7. The variance is simply the 864 over 7. It ignores the square root. Or if you already have the standard deviation, you just square it, because your calculator will give you the standard deviation, so you need to take that number and square it. So this should have been the, I think, 123 point... Yeah, 123.43. And again, with the same sample, we could compute the variance, because remember the standard deviation from the last problem was the square root of 500.67 over 2. We just don't need, for the variance, the square root. So it's just the 500.67 over 2, which is 250.335. If you want to round it, you can. So variance is easy once you have standard deviation. It's less of a shock. Variance really it's used in tests that we talk more about later. Yeah, for now though, you just need to know how to calculate it if it comes up on the homework. Now, let's talk about the empirical rule. When something is bell-shaped, or roughly bell-shaped, and doesn't have a skew, there's a relationship between the data and how many standard deviations away from the mean it should be. So here we have the mean in the picture. It says if you go 1 standard deviation, added or subtracted. So for example, if the average score on the test was 70, and that standard deviation was 5. If you want to go down a standard deviation, it would be 70 minus 5 to 65. Up standard deviation would be 70 plus 5 to 75. So let's say these are the expected scores on the test. It means 68% of the scores should be between 65 and 75. Now, I prefer that not be the case ever, but it could happen. And if you go another 5 up, 80 and 60, respectively, or 5 down, 95% of all scores, so 19 out of 20 scores will be between 60 and 80. And you just can, and then one more after that, 55 to 85, 99.7 scores would be between 55 and 85. Like, well, what does that even mean? It means about 299 out of 300 would be. Now, in order for something to be roughly bell-shaped, that would be unusual from a test score standpoint, but some things are. It's very hard for them to go out. For example, if you're talking about the size of an Oreo, like the radius, they don't really vary the size of the circles that much inside a package because machines are very consistent. So sometimes it's very hard. Standard deviations can be really small the more accurate you are. And we'll do some problems in the next video.